Okay, guys, let's jump into panel B and kind of close our thought here. So, panel B is going to be kind of similar, except the way I'm going to do this is I'm going to subdivide the surface into horizontal lines, and I'll deconstruct it, select those lines, and construct my triangular panelization. And then again, it'll have to have a rotator that is based off of the sun, or not sun position, the attractor point position. So the point at which I'm going to split the definition here is going to be from this loft. So I'm going to grab everything from here to here and pull that sort of upwards up there, and then I'm going to create another string of definition down below it. So in order to not be confused about all this, I'm going to turn all this stuff off and return back to my original panels. Okay, so like I said, these are going to be subdivisions, and they're just horizontal subdivisions. So I can go back and borrow my subdivide surface and subdivide all of these. And of course, make sure that you're getting rid of your vertical subdivisions. So those are going to be your U subdivisions. And that leaves me with just my V's. Should look a little bit like this. Feel free to create as many as you want. Probably don't go too skinny on these things because you're not really going to see much rotation if it's really, really skinny. In fact, I'm going to leave it pretty simple at 4. So something that I think a number of us didn't really do that I'm going to do is the right side of the panel is actually a triangulated depth to each of these. So I'm going to go through and do that first because the way that I'm going to construct this is actually off of it's going to be off of the spacing of these elements, and I'm just going to create sort of a point off of a curve that's going to return down to the bottom. I'll get there in a second, but in order to get there, I'm going to deconstruct this surface. Deconstruct the original lofted surface, because with that surface, I'm going to grab, using list item, one particular corner, quadrilateral 0 to 3, the top right corner, yeah, that's the top right, and I'm going to move that away, move that off the panel in the normal direction. However far I need to move it in order to get my depth that I'm looking for. So again, we're going to have to go back up here and grab the normal stuff here. So that's these three. And the normals, in this case, I'm actually going to generate them off of, I'm locking the solver, by the way. I'm going to generate them off of the individual faces. That way I have as many normals as I have surfaces in all cases. So this surface goes in there, the surface goes in here, and the surface goes in there. And then I'm going to unlock that solver. Now, I have a normal. If you turn this on, you'll see the plane is on each of the surfaces. That's good. I need to take this point and move it. So that's under transform, Euclidean, move. And that move is going to require a direction and a magnitude. So that means vector and amplitude. So this is our vector, and our amplitude is going to be whatever we set it to. So I'll say 0 to 5.00. And this is our point, which we can move out. You guys following along with that so far? So 5 is pretty extreme. I don't think I'm going to use 5. I'll move it back to maybe half of that. And so ultimately what I'm trying to do is to create a line that I'm going to subdivide so that I can create a triangulation for the panels. And that looks like this point needs to connect to the bottom right corner point. And so if I list item again, copy and paste that down, and grab the bottom right corner instead, which is this one, index item 1 for me, that's going to allow me to create a line using a curve primitive line from the top point to that bottom point. And there are the lines. Is that clear so far, guys? Okay, here's the key. As long as the top point is in line with the top edge and the bottom point is in line with the bottom edge, no matter what angle it's at, if I do an equal number of subdivisions, they are going to be aligned. Not to mention we're doing a triangulated panel, so technically it's going to create a real surface no matter what. So basically I'm going to take this number of subdivisions here and I'm going to use that to divide this line. So that's a curve division, and this is the curve I'm dividing. The number of subdivisions is the 4 from divide. Okay, so now you can see here the correlation between the two, right? So there's the same number of subdivisions between each of these along the edges. Are there any questions on that so far?
What's the name of the divide? It's not divide domain, is it?
Divide curve. Yep. All right, now I'm going to push forward and actually construct the triangulation. It should not be that difficult. The subdivision that we have here, the subdivision that we have here allows us to create a datum connection between each of the panels and the respective endpoint on this corner, right? So there are, they're in groups of 5. And we have 4 panels here, so we're going to have to actually cut out the last item in each of those 5s, but let's just kind of move forward here for a moment. So deconstruct this subsurface, and that's going to allow us to do another list item of particular edges in order to create a surface with it. So let me move my perspective over here so we can kind of watch the surfaces being created. Using list item, I'm going to grab the vertices, and I'm going to use a slider from 0 to 3, still quadrilateral. So index item 0 is the bottom left corner of these panels. Index item 1 is the bottom right, 2 is the top right, and 3 is the top left. So if I'm triangulating with the weight of it on the right, I'm going to use the top left, so that's index item 3. Now additionally, I'm going to use index item 2, which is the top right, for my back corner point, all the way up there in the top right corner of the panel. And then I'm going to use the divide point. I'm going to use the first of the divide points for the next one here. So let me create another list item. List item is so powerful, guys. So this and slider 0 to 3. There. Okay. So list item 0, index item 0 in this list of points is the top line. So all three of those align, which essentially means I can take using 4-point surface. I can connect each one of them, so that's going to be A, B, and C. Whoa! All right, we got something wrong here. 35, 140 values going in there, and 140 values going in here. So what's going on? Oh, I know. Yeah, so what's happening is, let me go back a step. So what's happening is it's going to every single one of the panels rather than just the top panel of each of these sets of panels, which is not great, actually. So let me see how I want to correct this. These B reps are coming in groups of 4.
How come that one only has 35?
Huh?
How come that item only has 35?
This one?
Yeah.
Because it's 1 point that happens in one place on each full panel, but these happen 4 times on each panel, or 5 times on each panel. So we've got to break it down to be paired up specifically in groups of 35. Hang on, I need to think about this for a moment. So this is what I'm going to try and do. I'm going to try to take the faces and flatten it and then partition it into groups of 4, which should give me my groups of each individual panel. So let's give that a shot. I'll flatten this, and then I'm going to do set list partition. I'm going to move these over. And I'm going to partition the list of faces by the number 4. And if I, and this is a test list item, I'm going to delete it in a moment. If I list item that, that's what I'm trying to do. There we go. So I could do it this way. Yeah, I probably don't want to list item those. And all right, so we've got the faces. Let's deconstruct those faces. So now my vertices are coming out again in groups of 4. Darn. Partition it. I don't want to have to do this every time. Let's try 0, 1, 2, 3, 4, 3. Okay. So this n equals 4 means that it's reading each face. Can I deconstruct that? And then if I list item, it's going to give me 140 of them. Actually, maybe I don't need this. Let me go back a sec to these. 140 might actually be okay, because if they're in groups of 4, what I need to do is reduce this list to be lists of 4. So I'm going to split that list and I'm going to do it by the first item. No. Split that list by the number of subdivisions, I think. Yeah. 4, B, okay, 140 items. There we go. Okay, that should be, I think, what we need. Let's give it a shot, though. I'm going to save this. Ah. Nope. All right. Let's do this much cleaner. Hang on. So I'm going to take this bottom set, move it down. This is going to allow me to kind of individually select each item I want. So if I go back to what I was doing before, and I partition the list, and then I select individual items. God. No. Yeah, maybe, actually. List item, 0 to 3. Let's go up to the top one here to get started. So with that particular item, I can deconstruct it. And then I'm going to grab one particular vertice out of that entire list. I'm just list iteming like crazy on this. 0 to 3. I want the top right corner. That's that one. Okay, so that should work as a pair, or a set, I should say. Let's give that one a shot. Freeform, 4-point surface, A, B, and C. What? 140, 140, and 35. Why are these creating 140? Wait, hang on. This is the back right corner that has 35. This one was not bake. I think I want to do it off of these panels. There we go. I think that's what I need. So this is the deconstructed version. Yeah. Okay. So I need to, I still need to list item off of the divide. So that's something I should have not done. List item, 0 to 3. Good to go. So this is going to take place of one of these. I have too many down here. This one is the back right corner, and it also has 35 items, so that's good. And then the, I don't know which one of these to use here. So I don't think it's going to be one of those vertices. I think it's going to be a copy off of one of these list items here. It's just going to be on the other side. So it looks like the problem I was having is that I needed to partition the list first. There we go. So if that's the back right, I need the back left. That's going to be this one. So let's give that one a shot. A, B, C. Ha! We got it. Okay. Okay. So I'm only going to do one of these right now, and I'll populate the rest of them moving forward. But the last thing, guys, the last thing in order to generate the rotator is moving that point. Okay, so each of these points is going to have to move based off of a rotation. And I think I'll actually have to do that tomorrow. We're kind of short on time here. Sorry that one took so long. That's a 20-minute video, but it took me a while to figure that one out. Questions? You probably have a few, but I'll work through them with you probably individually.